Today's topic is switching. A network is a set of connected devices. Wherever we have multiple devices, we have the problem of how to connect them to make one to one communication possible. One solution is to make a point to point connection between each pair of devices, like a mesh topology, or between a central device and every other device, a star topology. These methods, however, are impractical and wasteful when applied to very large networks. The number and length of links require too much infrastructure to be cost efficient, and the majority of those links would be ideal most of the time. Other topologies employing multi-point connections such as a bus are ruled out because the distance between device and the total number of devices increases beyond the capacity of the media and equipment. The better solution is switching. This is the switched network. Here, a switched network consists of a series of interlinked nodes called switches. Switches are devices capable of creating temporary connection between two or more devices linked to the switch. In a switch network, some of these nodes are connected to the end systems, for example, computer or telephone networks. Others are used only for routing. The end system communicating devices are labeled as A, B, C, D, and so on. And the switches are labeled as 1, 2, 3, 4, 5. Each switch is connected to multiple links. This is the taxonomy of switch network. The switch network may be divided into circuit switch network and packet switch network and message switch networks. And further, the packet switch network is divided into datagram network and virtual circuit network. The circuit switch network consists of a switch set of switches connected by physical links. A connection between two stations is a dedicated path made of one or more links. However, each connection uses only one dedicated channel on each link. Each link is normally divided into n channels by using FDM. FDM means frequency division multiplexing, or TDM means time division multiplexing. Here, the three phases of the system will be discussed later. This is the connection of the circuit switch network. The end systems such as computers or telephones are directly connected to a switch. We have shown only two end systems for simplicity. When end system A needs to communicate with the system M, then system A needs to request a connection to M and must be accepted by all switches as well as M itself. This is called the setup phase. A circuit channel is reserved on each link, and the combination of circuits or channels defines the dedicated path. After the dedicated path made of s- circuits, the channel is it established and the data transfer take place. After all data has been transferred, the circuit are torn down. It means there are three phases. First is the setup phase, then data transfer, and the torn down phase. In circuit switching, the resource needed to be reserved during the setup phase. The resources remain dedicated for the entire duration of data transfer until the teardown phase. This is the example of the circuit switch network. This is the delay when the data transfer from A to B. This is the total delay. Switching at the physical layer in the traditional telephone network uses the circuit switching system. Now we come to the next, which is called as, wait, 1 minute, datagram network. In data communication, we need to send messages from one end system to another. If the message is going to pass through a packet switch network, it needs to be divided into packets or fixed or variable size. The size of packet is determined by the network and the governing protocol. These are the two basic forms of packet switching, the datagram switching and the virtual circuit. In the datagram switching, each packet rated independently and packets can be taken any practical route. Packet may arrive out of order. Packets may get lost or delayed. Up to receiver to reorder packets and recover from missing packets. In the virtual circuit, pre-planned route established before any packet sent. Call request and call accept packets established connection, it means handshake. Each packet contains a virtual circuit identifier instead of destination address. No routing decision requires for each packet. Clear request to drop circuit. This is the circuit for a datagram network where A station want to send a data to the X, and it will send from 1 to 3 4. Then it can go up to any route and finally reach to the X. This is the routing table in datagram network. Thus, destination address defines which output port is used for sending the network. The switch in a data network uses a routing table that is based on the destination address. The destination address in the header of a packet in a datagram network remains the same during the entire journey of the packet. This is the delay of the datagram network. Switching in the internet is done by using the datagram approach to packet switching at the network layer. This is the virtual circuit network. A virtual circuit network is a cross between a circuit switch network and a datagram network. It has some characteristics of both. First, the virtual circuit network is it has two systems. One is the AND system and second one is the here is the second AND system.